So welcome student for this lecture on the CAN drilling cycle. In the earlier lecture we have seen how the CAN drilling cycle can be used. Basically it is used to reduce the production time or to increase the production rate when we have to drill the more number of holes. Okay, the basics already we have covered in the previous lecture. So from the reference position the drill will go to the feed rate mode, it will be retracted rapidly and then it will go to the next position. Okay, so you can drill the number of holes simultaneously with the help of the CAN drilling cycle code. We have seen this simple example also in the earlier lecture. To drill the hole B, C and D, and the lower left hand corner is your origin. Okay, so G81 code we have used, that is the CAN drilling cycle. So this is the position, hole B will be drilled, then hole C will be drilled and hole D. Okay, and G80 is your cancel CAN drilling cycle. So this we have seen. Let's implement this concept of the CAN drilling cycle with the help of the one example. Now in this example you can see we have to drill the 35 holes. Okay, the dimension of the plate is given, the lower left hand corner is the origin of the plate, the position of the hole is also given. Okay, now to drill these 35 holes. Okay, so we will drill this hole in column wise, first column, then second column, third, fourth and fifth column. Total 5 columns are there. Okay, we will drill first the first hole, first column, then second, third, fourth, like this. Okay, now let's see how it is CAN drilling cycle can be used to drill these 35 holes. Okay, now in this program, the percentage sign at the beginning, then the program number, G20 is the entry of the dimensional unit in imperial format. You can use the G70 also. G17 is your XY plane selection, G40 is your cancel cutter diameter compensation, G80 is the cancel CAN cycle, G49 is the cancel tool length offset, G90 is absolute positioning. Okay, so if any command is running during because of the previous program, you have to cancel that, otherwise it will affect on your program. Okay, so just as a precautionary measure we are cancelling these commands with the G40, G80 and G49. Now G92 it is used to show the machine where your 0 point of program is located with the X, Y and Z coordinate. Okay, M06 is tool change, we are using the tool number 1 from the turret. G00 is rapid travel to position 1, X 1.7, Y 2.4. So first column hole, this is the position of the first column hole, X 1.7, 2.4, RPM, then M03 is spindle on clockwise, then G43 tool height offset compensation in the negative direction, that is G43, Z is 1, tool register, that is H01, then coolant on M08, then G99 is your reference plane, G81 is the CAN drilling cycle, R we are selecting at point 1, it is reference plane is point 1 above the workpiece surface, that is the R, then Z is minus 0.4 and F is 3. So this will drill the hole at the first position. The first position hole will drill. X is 1.7, Y is 2.4. You can see X is 1.7 and Y is 2.4. So at this position the first hole will be drilled by N70. N70 will drill the position at the hole 1. Okay, now we are using this incremental positioning now, G91. Now after drilling the hole, now first column you can see. So we are drilling this first column with the incremental positioning with the increment of 2.1 in the Y direction, you can see. Now we have drilled this first hole. Now the first column hole will be drilled by increment of 2.1 in the Y direction. Okay, so this first column hole G91 is incremental positioning, Y is 2.1. How many number of times? 6 number of times. So you have to go incrementally 6 number of times. Y is 2.1, like this. Okay, so if you go 6 number of times, you will reach there. You will reach at the last hole. Okay, so as you reach to last hole will be drilled. Now you have to specify the X coordinate. X is what? 1.8. Okay, so after drilling the last hole, it will go to this position now. Okay, so it will go to this position. It will drill the hole at this position now in the second column. Okay, now as the hole is drilled at this position in the second column, Now incrementally again y will be minus 2.1. How many number of times? 6 number of times, you can see 6 number of times. Now y will be minus 2.1 because in the Cartesian coordinate system we are coming in the downward direction. Okay, so y will be minus 2.1 for 6 times, 1 2 3 4 5 and 6. Okay, so in this way holes in the second column will be drilled. Okay, holes in the second column will be drilled. Now x is 1.8. Now to drill the holes in the third column, now x is 1.8 means what? From this position x is 1.8, so we will drill the first hole at the third column. Okay, so after drilling the first hole at the third column, you can see now increment in y of 2.1 by how much times? 6 times. K is 6. Okay, so y 2.1 for 6 times, it will drill all the 6 holes in the third column. So once all the 6 holes are drilled in the third column, now x is 1.8. Okay, so from this position incrementally x will be 1.8. Okay, and in the fourth column y will be what? Minus 2.1 for 6 times. You can see minus 2.1 for 6 times. Y will be minus 2.1 for 6 times. Then the last column now. In the last column again from this point x will be 1.8, like this x will be 1.8, and from this point now incrementally y will be 2.1. Okay, y will be 2.1. This is the last column. Y is 2.1 for 6 number of times, that is the fifth column. Okay, so G90 is absolute positioning. GAT is your cancel can drilling cycle. Okay, because your can drilling cycle is running with the GAT1 code, so you have to cancel with the GAT code. Okay, so this command you have to use compulsory, otherwise the can drilling cycle will go on running. Okay, then GAT G28 is your return to the machine 0 point. Okay, Z10 is there. Okay, return to the machine 0 position. M30 is the program end and the percentage sign at the end. So in this way we can drill the number of holes simultaneously with the help of this simple incremental positioning and number of holes you have to write K6. We are writing here K6. How many number of holes we have to drill? 6 holes. Okay, so it will drill the 6 hole at the increment of 2.1 or minus 2.1. Okay, and after that you have to specify the x coordinate. Okay, so in this way we can drill the hole in the column, in the 5 columns. Okay, so you can see that your production time will be saved, your machining time will be reduced, and in this way you can increase your production rate also, or productivity can be increased very easily. So this is what the basic purpose of can drilling cycle in the drilling operation, and this is widely used in the CNC programming when we are drilling more number of holes in the component. So this was the lecture basically for the CAD drilling cycle, and in the next lecture we will see some new concept of the CNC programming in the coming lecture. Thank you.